ladies and gentlemen. Today we will be working on the Unit 6 Algebra A, specifically Algebra A, Study Guide Review. Now, this unit focused primarily on polynomials. So as you kind of look through the packet, you'll see a lot of these polynomials. And a reminder, polynomials are simply defined as having one or more terms. So if you're looking up at this first section, it actually breaks it down and says, instead of just calling everything a polynomial, let's be a little more specific and label things as monomials, binomials, and trinomials. And then, of course, anything that has more than 3, because again, trinomials would be a classification of 3, we then will just simply call it polynomials. There are higher classifications, but for this particular class, we're going to stop after trinomials and just switch into polynomials. Now, you'll notice there was a warm-up at the top of this paper. This process was a foiling process. I will not be spending time going over that because we'll be talking about foiling later in this review video, but just know that if you wanted a little extra practice, you could of course try to foil that or do the box method all on your own. So in this first section, I would like to remind you that a monomial has one term, a binomial has 2 terms, trinomial has 3, and then a polynomial, for the purposes of this class, we'll call it 4 or more. So when you get into classifying these, please remember that. So for this very first one, you'd look at this and say, oh, well, this has 3 terms, 1, 2, 3. However, if you remember when we talk about classifying, we always say that you must simplify before you classify. That's just kind of, it rhymes, so, you know, you kind of want to remember that. Simplify before you classify, right? So when you're looking at this very first example, you should notice that you have a 5x and a negative 8x. Those two pieces can come together, so you should make that a negative 3x plus 6xy. And once you have gone ahead and combined everything that you possibly could, now you can classify this as a binomial. All right, so that kind of reviews this top section as a whole. Couple of other examples. Here's one, and you know, frequently people see the x and the k and they think that makes it 2 terms. The plus and minus signs are pretty much what break up a specific term. So down here you see one term, right? Because it's broken up with that plus sign. So in number 2, there is really no plus sign at all. So this one's going to be considered a monomial. Again, be careful with number 3. These two pieces do end up coming together, so you're tempted to call it a trinomial, but when you bring those together, you'll actually see that what is 3 minus 3? These end up canceling each other out, leaving you with a negative 1, and therefore this one's actually going to be a monomial as well. I'm just kind of writing M for monomial, keep that in mind. Number 6, frequently people panic because of the parentheses, but you still have 1 term, 2 terms, so this is going to be a binomial as well. And then number 3, you're going to want to go ahead and distribute before you can kind of classify that one. When you distribute, you're going to get a 5x squared, because you have 2 x's, so that's where the square comes in, plus a 15x, and then at the end that plus 3. Now when you finish distributing that piece, you'd say, oh, let me check to see if anything combines. But in this case, you'll see that you have a 5x squared and a 15x. These are 2 different categories. And then the last piece doesn't have any x at all, so yet another category, making this a trinomial. So in this particular practice section, there were no polynomials, nothing that we particularly classified as a polynomial. But if you wanted to check out polynomials, I would recommend you go back through your notes to see a couple of examples of polynomials. Now, this next section kind of has a little bit of everything mixed in with it. You have some where there's an addition sign between them and some that have subtraction signs between them. You have some that have distributing, so you're going to need to take this this entire negative 6 and kind of distribute it. Versus the second piece, there's really nothing to be distributed there. You have some problems that are just distributing. There's no, like, you know, separate plus sign in between. This one's just distributing. A couple problems, you will notice that you just have negative signs to distribute. So don't forget that even the negative sign gets distributed. But let's look at a couple of these in more detail. Not all of them, of course. I want you to have plenty of practice. But I do want to kind of refresh your memory if you haven't done these since the first day of this unit. So in the first day of this unit, we looked at the comparison of these two types of problems. We said that with plus signs, that basically means that nothing is getting distributed, therefore nothing changes. So some of you guys in class practice just kind of using what was written out for you and combining like terms. And then others I suggested and still highly recommend that if you get yourself easily confused, just go ahead and rewrite everything. And then all of a sudden you just have one single expression that you are trying to simplify. So now I have a 6x to the third and a 4x to the third. I have a negative 2x squared, but that's the only one that's a 2x squared. I also have a plus 8x and a minus 11x. And then last but not least, I have this plus 10 on the end. So when I go ahead and combine like terms here, you should get a 10x to the third. Remember that when you're adding or subtracting variables, that the exponent does not change. The only time it changes is when you are doing multiplication. So in this case, I'm just adding. We also talked about possibly crossing them out once you've used them. That way you don't accidentally use them twice. All just different strategies. If you have your own strategy and you're like, well, I don't really like crossing them out, that's your own choice. None of this is a have to do. You could have just gone right off the answer and get to your answer. That's fine. These are all just suggestions or strategies that we've developed in class. The 8 and the 11 should become a 3x, and then that plus 10, he was the only one of his kind, so he's just going to stay a plus 10. All right, so again, you could have done that right off the bat here, and you could have gone into saying like, oh, here's one piece, here's another, that type of deal. I do want to remind you that that only works when you have plus signs. So over here with this plus sign, if you didn't want to rewrite this whole thing, you could just leave it as is because of a plus sign. The second you throw in a minus sign like in B, you at least have to rewrite the second piece because that negative sign is going to get distributed. So frequently people will write it like this, plus 18a squared, because reminder, negative, negative becomes positive. Some people just rewrite that top piece, and I've even seen this where they kind of scribble this out then. And then that way they know that they're dealing with this piece and this piece. That, you know, these are all just really shortcuts or different strategies individuals have developed. Find what works best for you. I personally prefer to rewrite the whole thing. Because if you don't rewrite it, I tend to get myself confused saying like, well, what do I use and what do I not use? So if you just rewrite all of it, even the new piece that you've changed, it just works out a lot better. And then you go through and you'll see I'm using colors right now. I find colors to be very helpful. If you're taking the test on this or a quiz on this and you want to grab some colored pencils, I am perfectly okay with that, and I'm sure whoever your teacher is would also be okay with that. But going onward, so I've now kind of classified everything, grouped them all together. So I have an a to the fourth, he's the only one. I have an a squared and an a squared, an a, and then a no a. So if I go ahead and combine my like terms, the 9a to the fourth is not going to change. Again, I cross it out, that's my preference. You have the negative a squared and the 18a squared. Reminder that technically when you have a negative a squared, there's a 1 right there. So if you like to write in the 1, that way you know that you have a negative 1 and a positive 18, making that a positive 17a squared. Cross them out. Negative 10 plus 3 gives me a negative 7a. Cross them out. And then, of course, that minus 6 is the only one of his kind. So that kind of summarizes combining like terms, which we did, you know, towards the beginning of the year. So you could always kind of check out. I think it was either Unit 1 or Unit 2 for my classes. And check out combining like terms if you're still struggling with that. Some other things that we've encountered, like I said, for example, 6, distributing. Remember that you're taking the entire negative 6 and distributing it. So that will become negative 6k to the fourth, and a negative 12, because negative 6 times 2, negative 12k to the third. And then, of course, if you wanted to do the rewrite strategy, like I suggested before, you could rewrite all of this, and then go ahead and combine your like terms and take it from there. That, I will remind you, is not your answer. I'm not going to take you through all of these entirely, just giving you some pointers. E is very special, and I like E a lot because you're distributing a negative 3, we're used to that. So, negative 3 times 4 would give me negative 12. But be careful when you take this r to the third and distribute it to the r squared. That's going to become r to the fifth. So remember when we said whenever you're combining like terms up here, you never change the exponent when you're adding or subtracting. Down here, I am actually taking negative 3r to the third and multiplying it. So under the rules of multiplication, that exponent does change. So addition, subtraction, it stays the same. Multiplication, it changes. All right, and if I keep going, you'll have a negative 3 becomes positive 9. And then again, r to the third r, that's going to change it to an r to the fourth. And then the last piece, that should become a plus 12r. Now that r to the third is the only one, so it'll stay r to the third. So kind of keep that in mind. You'll see that happening again here with the 5x, that when you take 5x times x, it's going to change the exponent. And then, of course, these actually last two examples have the same idea. You're taking a 5x squared, or sorry, 5a squared, and you're going to be distributing it, which is going to cause those exponents to change each time. And then this last one, you're taking a y and distributing it. And careful with the second piece, you are taking that negative as well and distributing that. You'll notice that whenever I talk about distributing, I personally always circle the entire piece that's getting distributed. That way I don't accidentally think that only the 3y is getting distributed, but it's actually the entire thing. The negative 3y is what's getting distributed. And that's important because in the second piece, when you distribute it, you'll see that you'll have a negative 3 and a negative 4 will make that positive 12y. So just kind of be careful with that when working through the rest of these problems. If I go ahead and move on to the second page of review, this was the section of Unit 6 that everyone absolutely loved, or maybe I'm misreading vibes. But this particular section, you had two options as to how to solve a problem like this. On the answer key, if you're looking at the answer key posted on Canvas, this particular one, I foiled it. But for this video, I'm going to change it up a little bit just so you can see both methods. And I'm going to show you the box method. Okay, so the box method, you actually have to draw in your own box. So hopefully you have that skill. And then going ahead and saying that I have an x plus 5 and an x minus 6. I do suggest writing in the plus and the minus symbol. That way you can become a little more familiar with what operation you're doing. So when you take, a reminder, when you're filling in the box, it's always multiplication. Okay, so just remember, when you're filling in the box, it's always multiplication. So x times x gives me, let me switch colors, x squared. Then I'm going to take a plus 5 and multiply it by x. That's going to make it positive 5x, because 5 times x is 5x. Negative 6 times x makes that negative 6x. And then last but not least, you have a negative 6 times 5 gives me negative 30. Now the final step, when you pull all of these numbers out, right? So we're going to have an x squared, a 5x, a negative 6x, and a negative 30. In theory, all of these are technically addition. You're taking an x squared, a 5x, a negative 6x, and a negative 30. You are technically adding all of these, and you are allowed to add a negative. So if you want to kind of look at it that way and just say, hey, I'm going to write out all these terms, and then I'm going to add them. If they happen to be negative, they happen to be negative. But you work with it, right? So right here I have a 5x and a negative 6x, which will make a negative 1x, right? And then, of course, at the end here, I have a plus negative 30 and an x squared out in front. Now, if you wanted to write this, and frequently people ask, do I need to include the 1? No, you can write it without the 1. Do I need to include a plus negative 30? No, you can just have a minus 30. But in my class, it'd be perfectly acceptable to write it either way. Okay. Now, as I mentioned in the answer key, if you're looking at the answer key, I did that one through foiling, but the second one I did through the box method. So again, I'd like to change it up just so you can see the other method. I'm going to do FOIL for this one. If you remember, FOIL stands for first. So I'm going to take 6x and multiply by 6x and get 36x squared. The O stands for the outside, so I'm going to take this outside piece, times it by this outside piece. So that's going to be your 6 times 7, and that should give you a 42. That should be negative, right? So negative 42x. The I stands for inside, so I'm going to take this inside piece and times it by this inside piece. So that's going to be positive 42x. And then the L stands for last, so I'm going to take the last piece of this one and multiply by the last piece of this one. Careful, because that is a negative 7, so that should give you a negative 49. And then if you just go ahead and say, hey, these two are matching terms, they both have x's. Now a negative 42 and a positive 42 ends up actually canceling it out, and it just happens to be in this problem. That won't always happen. But that means my final answer will have that 36x squared minus 49, and that's going to be your final answer. So the other two I'm going to kind of let you guys take a stride on, although I will give you some guidance, because sometimes you approach these problems and you're like, I don't know how to, even set this one up. So K, the big thing here is K has that squared in there. So frequently people are like, well, what do I do with that squared? I'm going to tell you right now that it simply means that there's two of them. So when you're trying to figure out how to set up the box method, maybe you're a big fan of the box method, and you're like, where's my two pieces? I need two pieces. It's because you have the exact same piece twice, okay? And then you could kind of do the box method or foiling for that one. And then the last thing that I'd like to mention is when you are doing I, and I'm actually going to show you the answer to I right now. When you're looking at I, you'll notice even in the answer key I wrote careful, because when you do the box method frequently, in class we actually talked about this, you can actually, some people do the circle method, and they say, hey, those are the two terms that are going to be added together. So you do negative 6x plus 5x. Be careful with this particular problem, because if you take a close look, when you look at that diagonal piece, this is a b to the fourth, this is a b squared. It's not going to add together. Those are two different categories, a b to the fourth and a b squared. Now I will say that, little hint, hint, this is a b to the third, this is a b to the third. So you could still technically do the circle method. It's just going to be this direction rather than before when it was this direction. Okay, so if you really like that circle method that I showed you over here, you can still do it that way, but in I, it's going to be this cross section rather than this cross section. So just be careful with I. That's the only difference there. M is one of the most popular problems, mainly because it's a good tie-in into geometry, which you will be taking soon enough. And to a lot of people, they look at this problem, they say, area, I'm writing it out, I have never learned area. But actually, they give you the area formula right here, and it says that area equals length times width. Well, right here, we're going to call this my width, and we're going to call this my length. So if I know that area equals length times width, you can simply say that you have area equals 5x minus 1 times 4x plus 7. And then all of a sudden it becomes a problem just like up top here, in which case you could choose to do the box method or you could choose to FOIL. Either one is perfectly fine. I will say that in my particular class we actually did talk about area a little bit, and we said, well, this is kind of like your box, right? So you could have your 5x minus 1 and your 4x plus 7, and then start doing your box method. That is area. So when we're doing the box method up here, we're actually finding the area of a box. All these numbers inside here is helping me find the area of the box. So technically this right here, this answer that we got, is the area. Area equals x squared minus x minus 30. And then of course when you get into carpentry or anything like that, area is very important. So here's an example of how you could find the area of something. The following two examples, N and O, are the kind of examples where you look at a person's work and you say, what did they do wrong? So frequently in my classes, I tell them to solve it by themselves first. So don't even look at the answer that they got and just solve the problem. So if I were to solve this problem, like on the front side, I would say, okay, well, this first piece, nothing got distributed. In the second piece, I need to distribute that negative sign, right? We talked about that on the front a little bit. You need to consider distributing the negative sign. And then if I go ahead and combine like terms, and then these y's combined, you should get a final answer of 5x, because remember that there's technically a 1 right there, 5x, and then there's technically a 1 there as well, minus 11y should be my answer. Well, when you look it up, their answer, their difference is right here. I got an 11, they got a 9. So then you ask yourself, well, how did they get a 9? Because simply saying, oh, well, they got a 9, you should have gotten 11. You need to actually tell them what they did wrong. Because if I handed back a paper and I just said, oh, you got 9, you should have gotten 11, you're not going to learn anything from that. You're going to be like, well, where did I go wrong? Because I thought I did everything right, but I got an 11, and you're saying, or sorry, I got a 9, but you're saying that it's 11. It doesn't really help you learn if you can't tell me what they actually did wrong. So if you say they got an 11, or they should have gotten an 11, but they got a 9, that's great. You know how to do it right, but you don't really know where they went wrong, and it's hard to kind of correct it if you don't know where they went wrong. What if you were the person that got it wrong, and me as a teacher came back and said, hey, it should have been 11? You'd be like, well, great, but why should it have been 11? They forgot to distribute that negative sign to the y, because if you look at this, let's say that you did 6x minus 10y minus x, because it went to the x, but then maybe they just left it as a plus y, right? Well, then when you start combining like terms, the 6x and the negative 1 will become 5x. Okay, great. So they're doing good so far. The negative 10y plus 1 would become negative 9y, and now you can see where they went. So they just did not distribute that negative sign, so they should have had a negative 1 in front of that y rather than a plus 1. Okay, so really having that honed in skill of saying what did they actually do wrong is very important. The next example is a very similar concept. However, you might just be able to look at their work and figure out what they did wrong. Because if you come over here and you say, okay, negative 56 plus 56, they cancel out, looks good, right? But if you come over to their box method and you start checking their work, well, you say 8 times 8 is 64, x squared, looks good. 8 times 7 is negative 56, true. Then down here, 8x times negative 7, then you should be, oh, wait a second, they should have a negative sign there. They lost the negative sign. Oh, no. And then this last piece, negative 7 times a negative 7. Well, what's a negative times negative? Oh, wait. Hold on a second. I'm looking at, yeah. Negative times negative should make that positive. Now, the reason that I stuttered a little bit is actually if you're looking at the packet that you guys got, I think this problem varies a little bit. So in the packet that my class got, it should be a positive 49. So it was correct in your packet, so let's not worry about that for a second. Let's pretend they had that positive anyways, because it might just be a slightly different version here, but the packet you guys got was a positive 49. But you'll notice that in both packets they lost the negative 56, so that's really going to be their issue, is that they should have had a positive 56. So right here, sorry, they should have had a negative. Right here, they should have had a negative. So again, I apologize, this copy of the review packet is slightly different, but if you're looking at the answer key of the review packet, let me zoom out just a little bit. There we go. You'll see that this is the packet that you guys got. The 49 is correct, and it's correct over here as well. It was really just that 56 that they lost, that it should have been a negative sign right there. Okay. And then the very last one is actually an advanced problem for those of you that love a good challenge. So I threw it on there just to see, see how many of you could figure it out. And a couple of you guys saw a problem like this in a packet last week and asked about it, and that's really good. But basically what it's asking you to do is, well, if we know how to FOIL something, let's say I come back up here and I look at a foiling problem, right? Or box method, either's fine. But you'll notice that the two outside pieces don't change. From the original to the answer, they don't change. X squared minus 30. However, these two middle pieces, they get added up to become that middle piece, right? So when you're looking at this last example, you should be saying, well, okay, what do I know? I know that this and this are not going to change. That's going to be an x squared and a 49. right? So in theory, along the top, you know that you're probably going to have an x up here, and you're probably going to have an x here. You're just not quite sure what numbers are going to go in there. So then you must ask yourself, well, what numbers do I know will multiply to 49? Because remember, these two numbers come together and get multiplied to this corner. So they're going to have to multiply to 49, but then they need to add to become 14x. So you think to yourself, what numbers do I know multiply to 49? Well, I know 7 times 7 multiply to 49, but do they add to be 14? In this case, 7 plus 7 gives you 14. 7 times 7 gives you 49. So these two numbers must be 7, 7. They must both be x's, because if you remember up here, they both usually have x's. And therefore, my corner pieces, or the outside pieces, this must be a plus 7, because I want a positive 7. This must also be a positive 7, because x times positive 7, positive 7. X times positive 7, positive 7. And then all of a sudden you get your answer. Now they did want it as a binomial. So what are the two pieces? Here's one piece. Here's another binomial. Two binomials. So 1, 2, binomial, 1, 2, binomial, and that would be your final answer. So reminder that's kind of an extra challenge problem. That is actually going to tie us into what we're going to learn in the next unit, but I'm not going to dive too much further than that into that one. So hopefully this review video has kind of helped either refresh your memory, maybe if you're just watching this right before the test, refresh your memory, or at least help set you up with a couple problems that maybe you were stuck on, like K, if you were stuck on that, or on the front page combining like terms. So I wish you the best of luck with your polynomial test.